perform descriptive statistics using Excel. Tomorrow is a day 2 because yesterday we have not completed the topic which we need to cover in the I am in a session. So yesterday I think whatever I have not covered today, I'm trying to cover that. So I think we have left with the chi-square test, right? Hello.
Yes, ma'am.
Fine. So I'm expecting you. Just a minute. I'm also opening my sheet. Actually, I just came from the meeting. So I'm just opening my sheet. Fine. Yeah. Okay, I shared my screen. I hope it is visible to every one of you.
Yes. Yes, ma'am.
Fine.
Yes, ma'am.
Thank you. So I think one of you have asked me about give you some homework so that you can come prepared to understand today's session. So I talked about you to the term non-parametric test. Anyone who have gone through and understood the concept can tell me what do you mean by non-parametric test?
Ma'am, like probability.
Okay, like probability means I'm not getting clearly, ma'am. Yes. It's not clear. Can you tell me again? Or anyone else who can add on? What do you understand by term non-parametric test?
Parametric means based on sample and population.
Very good. Okay.
And non-parametric, actually, I'm not recalling that much, but I remember this. Non-parametric is based on sample and population, not based on sample and population. I thought.
Ma'am,
Fine.
for parametric test, there are certain assumptions that they will follow the normal distribution, variance is constant, and population has certain parameters. But when these parameters are not available with us, we normally apply non-parametric test.
Fine. Fine. Thank you so much, ma'am. Fine. So I think you people have tried to explain me the concept beautifully. When I want to keep my opinion, I say when we talk about the parametric or non-parametric test, we are talking about the inferential statistics, right? We can divide statistics into the two parts, descriptive and inferential, right? So when I say inferential statistics, meaning is what? When you want to infer population parameter using sample statistic, you are talking about inferential statistics. Meaning is that, say for example, I'm talking about hypothesis testing, right? In hypothesis testing, generally what we are doing or what we are saying, suppose I have made my hypothesis like there is no significant difference in mean satisfaction score of male and female respondents. Although I have not mentioned that I'm talking about satisfaction in what context, but whatever context you are taking satisfaction for any product or any services, you can mention that. Broadly, I'm saying there is no significant difference in the mean satisfaction score of male and female respondents. I think hypothesis is quite clear. What I have written here, that statement is clear. What this statement is telling us, it is simply saying us that the score of the satisfaction score, mean satisfaction score of male and female is same. Is it okay?
Yes, ma'am.
Right. So usually if I am conducting any study, generally what we are doing, we are conducting a study on the basis of sample, right? We are generally drawing a sample from the population, right? So when you are talking about a sample, generally whatever we are concluding using the sample, we want to make it generalized, because whatever my results are saying, I want to generalize those results. That means I want to apply those results on the population. So here generally, if you have seen the symbolical hypothesis, you have generally observed this thing. Generally here we are writing mu1 is equals to mu2. That is population mean 1 is equals to population mean 2. Means mean person's population or mean people or the population of the mean, their satisfaction score is equal to the population mean score of the female. This is the meaning of this. So generally, whether we are knowing it or not, but generally when you are making your hypothesis, generally we are comparing the means of the populations. Although we are using the sample, purpose is what we want to conduct our study and we want to generalize our results for the population. So that is why this is the main purpose. So here what I'm saying about inferential statistics, I'm saying I want to infer population parameter using sample statistic. Means using the sample characteristics, I want to comment or infer the population characteristics. Parameter and statistic, nothing but meaning of both is characteristics. Means if I am writing here, characteristics meaning is parameter, it is for the population, or statistic, it is for the sample, right? So I want to use sample statistic to conclude about the population parameter. This is the whole meaning of the inferential statistics, right? Now to infer or to conclude or to whatever hypothesis we have made, to test that hypothesis, we need to use certain statistical tests. Those tests can be divided into the two categories, that is non-parametric and parametric, right? Today I'm talking about the non-parametric test category. So where we are talking about the non-parametric test category, so where I think one of you have already said, there will be generally certain assumptions. And in the parametric test, assumptions are generally roaming around the variance and the normality, right? So non-parametric tests are those tests which are not considering the normal distribution of the data. They are not bothering about that your data is normally distributed or not. So in that case, we are using non-parametric tests where maybe our data is not following normality assumption, right? Or not following any assumption of the parametric test. In that case, we can go for the non-parametric test. Or when we are having the categorical data, we can go for the non-parametric test. So these are the conditions. On the basis of that, we are deciding whether we will go for the parametric test or non-parametric test. So condition number 1, when your data is not following the assumptions of parametric test, in that case, you can go for the non-parametric test. Second condition is when your data is categorical in nature, in that case, you can go for the non-parametric test. I hope condition is clear.
Can you please repeat it more?
I said when your data is not following the assumptions of parametric test. Second is when your data is categorical in nature. Done? Is it fine? Clear?
Yes, ma'am.
So
हम ऐसा कहेंगे कि जब डेटा पे नॉर्मल डिस्ट्रीब्यूशन एप्लीकेबल ना हो उस कंडीशन में हम लगाएंगे नॉन पैरामीट्रिक.
usually main purpose, usually people are going for the parametric test, right? So
Okay.
if you are checking the assumptions and your data is not meeting the assumptions of parametric test, you can go for the non-parametric test. Because in non-parametric test category, for every parametric test, we are having a test available which we can apply from the non-parametric test. So substitute is available there.
Okay, ma'am.
Now, here today I'm talking about the chi-square test, which is one of the non-parametric tests, right? So when you are talking about chi-square test, first thing is it is non-parametric, right? Second thing, it is based on categorical data. Or for categorical data, you are using the chi-square test. Purpose is you want to see the uniformity frequency. Whether the frequency is same or not, this is what you want to check, right? So those who have already gone through the or have understood or applied or maybe studied chi-square test, they are knowing chi-square test is talking about the count of the data. Count of the data meaning is that we are talking about the frequency. So chi-square, because in categorical test, it is only possible to take a count of the data, right? Say for example, I am having the gender, right? I am having the weight. You can easily understand these with the help of these two variables. Example, in case of gender, I will be having a data of male, female, right? But in case of weight, I can have any value. Maybe I can have a weight of any person is 45.6, 50, and then maybe it is 60, sorry, 62 or something like that, right? So now you can see when I'm talking about a categorical data, gender is a categorical data or categorical variable or nominal variable, right? And in that case, I can only take a count, how many of the male, how many of the female. But when I'm talking about the weight variable, weight is a continuous variable. There I can measure the weight of a person. So gender cannot be measured, but weight is a variable which can be measured by us. Is it clear?
Yes, ma'am.
Yes. So when I'm saying categorical data, so you need to have categorical variable available with you. You are having their data available with you. You can take a count of that. So chi-square test is totally based on the frequency of the data, right? And in case of frequency, we want to see for every category whether the frequency is same or not. This is the main purpose of chi-square test. Now, there are two types of chi-square test. First one is goodness of fit. So goodness of fit chi-square test. So I think firstly I'm taking the name and I'm explaining here this, and then I'll take the second type, right? So goodness of fit test is a chi-square test which is considering one categorical variable, right? So one categorical variable, but there can be the multiple categories, right? So when you're talking about chi-square goodness of it, you will be having a single categorical variable, but in that variable there can be the multiple categories. Say for example, gender is a categorical variable, right? And I'm having only two categories here. So you will be having any categorical variable available with you, and there can be the multiple categories. Say for example, preference of color. Suppose I have given some choices to the respondents, like maybe black, white, green, pink, and maybe blue, right? Suppose these are the some of the choices that we have given. Now we are asking the preferences from the respondent, that which color they are liking most. So suppose I got here 15 people are saying, or maybe 25 people are saying they are liking black, 20 are saying they are liking white, 10 are saying they are liking green, suppose 18 are saying they are liking the pink, 12 are saying they are liking the red. Getting? So you can see here there are 5 categories of the preference of color, and these are the count. Is it clear?
Yes, ma'am.
Right.
Ma'am.
So purpose, sorry, is it okay? Shall I proceed?
Yes, ma'am.
Yeah. So purpose is what here in the goodness of it, I want to see whether this count is equally distributed in all the 5 categories or not, right? So what I need to see here, I can take means, just a minute, I'll enter one more row. Yeah. So I can say this is nothing but this is the observed frequency. This is I am observing how many of the people are liking black color, white color, and other color, right? Now I need to compare this frequency with the expected frequency. So what I'm expecting that the count should be same for all the 5 categories. So what I'll do, I'll take a sum of this, which is coming as 85. 85 divided by 5 is 17. That means I'm expecting for all the categories, this should be the 17, 17, 17. Is it clear? So I want to see the uniformity of frequencies. Is it clear?
Yes, ma'am.
So this is about the goodness of fit. In this case, how I will make my hypothesis? I generally write my null hypothesis as there is no significant difference in the observed and expected count of color or color preference. Fine. Is it okay?
Yes, ma'am.
So this is a very simple form of chi-square test, which is known as goodness of fit. Now we will move about the independence of attributes. Independence of attributes is the second type of chi-square test, where other name of this is test of association. So I can say independence of attributes or test of association. That means here I need to have 2 categorical variables. And I want to see whether the 2 categorical variables are having any association or they are independent of each other, right? So in that case, my null hypothesis will be there is no association between both the categorical variables. Then, or you can write, other way of writing the null hypothesis can be categorical variable 1 is independent of categorical variable 2. I hope hypothesis is clear.
Yes, ma'am.
So in case of independence of attributes, we need to talk about the term cross tabulation or contingency table. Right? Cross tabulation or contingency table. So we can say we need to have, as I said, I told you, we will be having 2 categorical variable. So it is quite obvious categorical variable having their categories, because name is itself categorical. So they will be having categories. So you will list down the categories of one categorical variable in the column, other categorical variable in the row, and in the combination of both, you will write the count. So for example, suppose I am writing here male, female, yes and no. So maybe my variable is gender and I'm asking about whether they are reading magazines or business magazine or not, right? So one categorical variable is gender, second categorical variable is reading of magazine, right? So whether they are reading the magazine or not, so it is yes or no. So how many of the males are reading the magazine, business magazine? So maybe suppose it is coming as 35, it is coming as 10. It is coming as suppose 10 and it is coming as suppose 35, not maybe 45, right? So that way I can say it is 45, it is 55, total is 100, column total is 55 and it is 45. Is it clear?
Yes, ma'am.
It is known as contingency table or cross tabulation. That means ultimately I'm having a count. So these are the observed frequencies. This is the observed frequencies. I observed how many of the males are reading the business magazine, how many of them are not reading the business magazine, how many of the female respondents are reading business magazine, how many of them are not reading. So this is the observed frequency, right? In case of goodness of it, you have seen how I have calculated the expected frequency. I have taken only the average of this. You can see I selected the column, and maybe if you can see my screen clearly, you can see at the bar, you can find at the below bar, you can find this. It is showing you average is 17, and same I have written down here, right? But when you are using the contingency table, here the formula is different for calculating the expected frequency. And I think I need to let you know or make you clear this thing here. Why I'm telling you these calculations, because Excel is not having any function which can give you directly the calculation of these expected frequencies, right? Miss, I think yesterday when I told you talking about this data analysis tool pack, you can see once you will go to your data analysis tool pack, you can click on that, and you can scroll down the whole list. You can see there is no chi-square test is listed. Getting? So the problem is that using the data analysis toolpack, you cannot apply chi-square test. You need to use a function, and function is requiring you to provide the observed frequency and contingency frequency. So observed frequency you can easily collect, right? So that way you can say these are the observed frequencies. Now problem comes, you need to tell how to calculate the expected frequency. So in case of goodness of it, I think you can see it is very easy. I'm writing here the formula in case of second type of chi-square test, that is test of association. In this case, your expected frequency will be calculated as row total multiplied by column total, and this will be divided by grand total. Right? So you can see this is first row. So this is your first row total. This is your row total 1. This is your row total 2. Similarly, this is your column total 1. This is column total 2. And this is your grand total. I hope it is clear.
Yes, ma'am.
So if this concept is clear, I think hypothesis I already told you. Now I think we are all set to perform chi-square test using the Excel. So shall I go for the chi-square test performance?
Ma'am, one query.
Yeah.
Ma'am, why do we need to make a contingency table for the test of association? Is it because there are two categorical variables?
Yeah, it's cross tabulation.
Okay.
Yeah.
Ma'am, can we use the ordinal variable also in case of the cross tabulation or contingency table?
Possible. There is no problem. You can use it, but usually nominal scale variables generally we are using. But if you are having categorical ordinal scale data and you are having the count of that, you can go for that. Count is important in case of chi-square test.
Okay.
So maybe suppose you are asking about the rating of the product. So suppose you have written rating 1 means rank 1, rank 2, or rating 1, 2, 3, whatever. So how many candidate has given rating as 1 for that product or services? For 2. So if you're having count, you can go for performing the chi-square test.
Okay. Thank
Ma'am,
Yeah.
one question.
Yes.
Ma'am, there is a row total 1, row total 2, and in expected it is RT into CT.
So expected count will be calculated 4 times, no ma'am, because you are having 4 observed frequencies, no? So 4 times you need to calculate the expect. I think that we will do manually when we will go for the calculations. So you do not go into this R1, R2, RT1, RT2, and CT1, CT2. We will go and calculate in the second kind of chi-square test, and then I'll explain this, right?
Okay.
Fine. So if no more questions, shall I proceed? Or if you are having any other question?
Ma'am, one doubt.
Hmm.
Ma'am,
Yeah.
this HO is null hypothesis. Is it like that?
Yeah, HO or H0, H0, it is null hypothesis.
So we should have H1 also, no? Or only null hypothesis is enough.
Up to you. If you want to mention both, you can mention both. Nowadays, there is a question, people are only mentioning alternative hypothesis, the research hypothesis. Okay. Yeah. But test is always applied on the null hypothesis. This is the important thing to understand. So results which we are getting, or the hypothesis which we are testing is the null hypothesis. Okay.
Yes, ma'am.
Fine. So I need to, so means I can request you, I think yesterday itself I shared the sheet of chi-square test, right? So open the sheet and open a sheet, worksheet named as demo GOF. That this is what you need to open. Open, everyone.
Yes.
Okay. So shall I proceed to tell you what is the problem given to us and how we can solve it?
Yes, ma'am.
Fine. So you can see we are having a table given and there is a statement written. The table shows the number of people absent on a particular day in a week, right? Okay. So I think maybe I missed the complete problem writing here. No issues. Now you can see we are having, suppose there is a school which is opening or working or operating on 5 days of the week, Monday to Friday. And these are the count given. These are the absenteeism count given to us, that how many of the people were absent on Monday, Tuesday, and likewise for the remaining days. So this is the count given, right? Clear?
Yes, ma'am.
Fine. Now we want to see whether the absenteeism distribution is same throughout the week or not, whether the absenteeism distribution is uniform throughout the week or not. This is what we need to check. Is it okay? Problem is okay, clear?
Yes,
Ma'am,
ma'am.
can
Yes,
you
ma'am.
repeat what we have to find once
We need
again?
to, okay, we need to find here, or we need to check here whether the absenteeism distribution is uniform throughout the week or not.
Okay, ma'am.
Fine. So as you can see, we are having a single categorical variable available, which is the absenteeism, right? Absenteeism on the different 5 days or 5 days of a week, right? So single categorical variable, and as I told you, the problem is you need to see the uniformity of the absenteeism score, right? So we will go here to perform the chi-square goodness of fit test. Before performing it, firstly, I will write my null hypothesis, which says there is no significant difference in the observed and expected absenteeism spelling is this only, count, right?
SPN, ma'am.
I will be there, no? No?
Yeah, SPEI,
Yeah, that is, I think I have written it.
SEN, it will be.
Yeah. It's ISN, right? Mhm. Is it fine? Oh, you, I think,
Ma'am,
just a minute.
SEN, it will
Yeah,
be.
you, I think it is fine. So if this is my null hypothesis, alternatively, if I want to write my null alternative hypothesis, if I want to write, what I will write, there is a significant difference in the, yes, fine.
Yes, ma'am.
Fine. So null hypothesis and alternative, both the hypotheses I have written here. I already told you we want to perform here the chi-square goodness of fit. And chi-square goodness of fit is requiring two types of frequencies. One is the observed, second is the expected. So observed frequency is already given to us. Now we need to calculate expected frequency. So I think I already told you how to calculate expected frequencies here by getting the average of the observed count. Yes or no?
Yes, ma'am.
right? So maybe I can write here function average, right? I'll select the complete range and I will freeze the range because I want to copy the same formula to throughout the remaining 5 cells and I do not want to change the range. So I have freezed it using the function F4 key from my laptop. Or maybe if you wish manually also you can put a $sign to freeze the range, right? And then I can drag it also. So you can see I'm getting 100, 100, 100, right? Fine, everyone.
Yes.
So I think everyone has got the expected count. Now shall I go for performing chi-square test here? Yes.
Yes.
Fine. So before performing chi-square test, I want to ask you, once you are testing any hypothesis, how you are deciding it, whether you are accepting it and or whether you are rejecting it. What is your criteria? How you are deciding it to accept or reject any null hypothesis? Anyone?
On p-value, if p-value is less than 0.05, we fail to accept the null hypothesis. If p-value is more than 0.05, we accept the null hypothesis.
Okay, very good. Any other criteria or only single criteria is there?
Madam, same madam, based on p-value, calculated p-value and tabulated f-value, if we are doing manually, then we will consider calculated versus tabulated f-value.
Very good.
And
Right,
like
so-
ma'am said, yeah, we'll consider p-value if null, like if it is less than 0.05, then we will reject the null hypothesis. If it is more than 0.05, we will accept the null hypothesis.
Very good. Thank you so much, ma'am. Ma'am has made my problem very easier now. So I think there are two approaches. One approach is the p-value approach. Using p-value, you are deciding whether you're accepting or rejecting the null hypothesis. Second approach is the critical value approach, right? So there are two approaches. Those who are new, they can understand or write p-value approach. And second one is the critical value approach. P-value is what? Here you need to compare your p-value with your level of significance. Level of significance means some percent you are deciding that this is the error percent, and on the basis of that you are comparing whether your p-value is less than or greater than to that. If it is less than, you are rejecting your null hypothesis. Opposite to this, if p-value is greater than your level of significance, you are going to accept the null hypothesis, right? Critical value approach says you need to compare your critical value with the calculated value. Means whatever is the calculated value of chi you are getting, you will compare that value, that is critical value, or that is a table value, right? So when your calculated value is less than your critical value, right? So in this case, you are going to accept the null hypothesis. Opposite to this, when your calculated value is greater than your critical value, you are going to reject the null hypothesis. Then these are the two approaches. But being the facilitator of this program, I need to tell you, those who are new, because nowadays we people are using softwares for checking or testing our null hypothesis. So we are based or selecting the p-value approach, right? So if you are new, you can keep only one approach in your mind. But if you are well aware with the second approach also, it is no problem. You can go with this because these are little confusing. People can get little confused when they are using two approaches. So up to you. In whichever approach you are comfortable, you can go with this. I will suggest you go with the p-value because softwares are providing us p-value, and using that we are deciding whether we need to accept or reject the null hypothesis. Okay, I hope I am clear on this.
Ma'am, how to find LOS means level of
Level of
significance?
significance, ma'am, this is decided by the researcher. Up to, means what is the risk level of yours? Up to what level you can take the risk? Generally, mostly used are the 5%, 1% and 10%. But it is depending upon the discipline you are using. In the medical discipline, we cannot take 5% or 10%, are very high risk percentage, where there is a means it is a what I can say scenario of the death or life of a person. So there, with this person we cannot take. So their LOS will be very small, depending upon the discipline. But as I belong to the management side, so my discipline comes under the social sciences. So generally in social sciences research, 5% people are generally, means 5% generally people are taking as a LOS, level of significance.
Ma'am, only one more question. Ma'am, in the Excel sheet, how can we identify? Means the question is the table shows the number of people absent on a particular days in a week. So how can we identify? We have to apply chi-square test here.
I think I started with the same, ma'am. I said there is one categorical variable. Absenteeism, according to the days, is given. Absenteeism is given in the count form.
Okay.
It is count how many of the students were absent on Monday, Tuesday, Wednesday, Thursday, or Friday. So this is the count given. So when it is a count, it is quite obvious we cannot go for the parametric test. Parametric test is talking about the value of the variable. But here we are having the count of the data. So in case of
Okay.
count of the data, we need to go for the non-parametric test. So second thing we have checked, we are having here the single categorical variable available. I told you we want to see the uniformity of the frequencies. So I said we will go for the chi-square goodness of it.
Okay, ma'am. Thank you. Actually, due to network issue, I'm unable to listen.
No problem. Is it fine?
Yes, ma'am.
Okay. So shall I go for the performing of the chi-square test now?
Yes, ma'am.
So you can see some of the functions I have provided you with the name. You can see p-value, for p-value or for getting the p-value, we need to use chi-square dot test function, right? And then we need to provide the range of the observed frequency and expected frequency. I have made the notations very easier for you. So I'll show you this. Suppose I want to get a p-value, right? So what I'll do, I'll put a equal sign. I'll type here chi-square dot test. So it is depending upon the version which you are using. Maybe in other versions it can be CHISQ, and without dot test is written, right? And then you can see it is asking you for the actual range and expected range. Actual range means the range of the data which is observed frequency. So I have selected the first range which is under the number heading. Putting a comma, I selected the second range which is we have counted. These two ranges I have provided. I have closed the bracket and then I'll press enter. So I hope you have also got the same B3 colon B7 comma C3 colon C7. Is it okay? Shall I go ahead?
Yes.
Wait.
Okay.
Ma'am, please one time repeat.
Equals CHISQ, you can type. So you will see the prompt. From there you can select the function this, and then you need to select the first range which is below this number, and then second range below the expected frequency. These two ranges you need to select.
Okay, ma'am.
And then press enter. After closing your bracket, you can press enter. Done?
Done, ma'am.
Everyone is getting figure like 0.027.
Yes, ma'am.
So I can think you can see now this is a p-value available with me. I need to compare this p-value with the level of significance. Although I have not mentioned the level of significance, but for this kind of study or this kind of hypothesis, I think 5% is okay. 5% risk we can take here, right? If there is any error in the data, 5% risk is okay. So I will compare my p-value with the 0.05. 5% meaning is 0.05. So you can see when I'm comparing the 0.027 with 0.05, it is less than. My p-value is less than level of significance. It is okay? Yes? Everyone, it is fine?
Yes, ma'am.
So if this is a rule, p-value rule says if your p-value is less than your level of significance, what you will do? You are going to reject the null hypothesis. Yes? Fine?
Yes.
So what I conclude here, I will not go with my null hypothesis. I'll conclude my result that there is a significant difference in the observed and expected absenteeism count. Right?
Yes,
Throughout
ma'am.
Fine. So this way, I think you can understand how to perform chi-square goodness of it. Not tough. It is okay. Easier for everyone to perform. Everyone, fine.
Ma'am, just
So-
one question.
Yes.
If there is outliers, like many outliers in the data.
Ma'am, this is a count. This is a count data for count in case of the non-parametric test. We are not talking about these things. Usually, when we are talking about the parametric test, then outlier or checking of outliers is one of the assumptions. There you need to check variance, homogeneity of variance. You need to check about the normality of layers. There you need to check that.
Ma'am, suppose on some day like Friday, there is only one absentee. Won't be considered as an outlier?
Ma'am, in that case, chi-square assumptions are a little different. Chi-square assumption says expected count should not be less than 5. So
Okay.
we will not see the observed count because that is not in your hand. We will see the expected count there, and we will see expected count should not be less than 5.
Okay.
Right? So assumptions of chi-square test is different because it is a non-parametric test. So it is not talking about that thing.
Okay.
Fine. Is it okay? Shall I go ahead?
Yes, ma'am.
Fine. So friends, next sheet, practice GOF, that is goodness of fit is for you, that you can use for your practice. I come to demo IOA, independence of attributes. I hope you all are ready. Can we go with the next thing? Yes. Friends, shall I go ahead?
Yes, ma'am.
Fine. So now you can see I'm having, I'm presenting you the second example, which is related to the independence of independence of attributes or independence of association or test of association, right? There you can find, I have given you two columns. But one is the wealth status, second one is the graduation status. In the wealth status, you can see you are having wealthy, middle, and the poor. These are the three status given here. And in the graduation status, there is yes and no. Two things are given. Fine. Is it okay? That means I am having two categorical variable. First one is the wealth status. Second one is the graduation status. Okay. And in the wealth status, I'm having three categories, whether the person is wealthy, middle wealth status he is having, or he is a poor person. In the graduation, I am having two status, whether the person is graduated or not graduated. Okay. Two categories and three categories. This data I am available here. So I can say I'm having two categorical variable available with me. Is it okay, friends?
Yes.
Fine. Now, I need to formulate my null hypothesis. So I think this data is perfect for contingency for performing the goodness of, test of association or not. Two categorical variable available. I want to find here whether these two categorical variable are associated to each other or not. Means whether the wealthier status or wealth status is dominated by the graduation status. This is what I want to check, right? So I will make my hypothesis as wealthy status is independent of graduation level, or I can write there is no association between wealth status and graduation status. So this will be, or this will be my null hypothesis. So one of them. It is not like both the type of hypothesis you need to mention. Any one which you are finding more appealing to you that you can use for writing your hypothesis. Right? Note it down, everyone. Shall I go ahead?
Yes.
Fine. Now you can, I think I have already given you this particular blocks or not available with you.
No, ma'am.
Not. So I'm giving you few seconds. You need to make, what you need to do, you need to prepare a table like this, right? You can give yes and no and wealthy, middle, and poor. These three status you need to prepare. That means we are preparing here the contingency table for the observed frequency. Graduation level I have taken in the column and wealthy status I have taken in the rows. And then total of row total and the column total I have taken here. Done, everyone? Prepare this. Means only one you need to prepare and then you can copy. For expected frequency, you can copy only this portion. Fine? Fine, everyone? Or I need to prepare along with you as you say. Do I need to show you how to make it? I think it's not tough. You can prepare it. Yes or no?
Ma'am, just give us 2 minutes.
Yeah, I'm giving you. I'm just asking.
Give us 2 minutes, madam.
Fine. I'm giving you. I'm just asking. Do I need to show you how to make it? Or you can prepare by your own? So only table number one. Okay. Only make table number 1 and then you can copy paste. You can copy this portion and make this one and this one. Only one table you need to make and then copy paste you can do. Done?
Madam, do three tables, huh?
Yeah, one you need to make and then you need to only copy paste, ma'am, like this. And if you are not making this, there is no problem. This is only I have written to make you understand how to calculate expected frequency. Only this one and this second one, expected frequency. These two only you need to prepare.
Done. I will wait for others, madam. I do.
Okay. So once everyone is ready, please tell me so that we can proceed.
Madam, for every ANOVA, we have to do this chi-square test, ma'am. Like, is it necessary?
For every ANOVA?
Before every ANOVA, we should do this, ma'am. Like, because
ANOVA,
it actually tells.
Ma'am, I'm not knowing where the ANOVA is coming in the picture. ANOVA, I think I haven't talked about right now.
No, ma'am. My question is, before doing ANOVA test, is this chi-square test necessary, or both of them have no
there is no linkage.
relation?
There is no
Okay,
linkage
ma'am.
between these two. In ANOVA, concept is different. In chi-square test, concept is different, ma'am. Chi-square test is a non-parametric test. It is based on categorical data. In ANOVA, we will be having your continuous variable also available with you. Numeric variable will be having with you. Right? So purpose is very different. There you are talking about the mean differences. Here we are only talking about the uniformity of frequency, whether the frequency is uniformly distributed or not. Right?
Okay, ma'am.
Yeah. Ma'am, from which field you belong to?
Me, I'm from English language teaching, madam. Not from literature, but only ELT.
Okay.
When I submit papers, no, I am required to do ANOVA test.
Okay, so ANOVA we are going to see maybe on the after tomorrow. Tomorrow I'll take t-test. After that I'll take the ANOVA.
I thought because this chi-square test is dealing about the frequency, maybe we should do, ma'am. I'm not from maths background. No, this is very confusing.
Nothing to do with the maths background, ma'am. It is related to statistics. And even if means even I'll say it is not like we are from statistics or maths or whatever field. We are academician and we need to complete the research. We need to do our research. So we need to
Yes,
understand the
ma'am.
concepts of research. And I think I tried to explain you the concept of variables. You need to very much understanding this thing that what are your variables and how you are measuring those variables. So here you can see I told you I'm having a wealth status. So how I can measure a wealth status? I can only see whether the person is wealthy, he is a middle wealthy person, or he's a poor person. So he or she himself is telling that he belongs to the wealthy category, middle category, or poor category. Similarly, whether person is graduated, so if answer will be very much obvious, it is yes or no. Person will himself tell you whether he is graduated or not. So that means I can only count how many of my respondents are graduated, how many of my respondents are belonging to the wealthy status or middle wealthy status or poor status. I can take
Yes,
a
ma'am.
count here, right? So that means I can only count it, but I think I have just given you one more example of weight. In case of weight, I cannot count the weight. I can measure the weight. Weight is having some value,
Yes, madam.
right? So that is a difference. You need to understand how you are measuring your variable. That is very much important to understand. Okay. I
Yes,
hope now
yes,
everybody is
madam.
ready. Yeah. Thank
Done,
you.
madam.
Yes.
Done.
Done. Fine. So, friends, now I'm requesting you, please do not do anything. I don't know how many of you are comfortable with Excel. You need to only see me, what I'm doing here, right? So, see what I'm doing here. If you are good with Excel and you are knowing how to perform filter, I'm telling you, I selected, suppose I selected this wealth and graduate. These two headings are selected. I'm here on the home tab. I'm going to the extreme right. Short and filter is available here. I am clicking on the drop down and selecting this filter icon. So you can see there is a filter applicable here. Now what I'm doing, if you will see my contingency table, I want to see how many of the persons, those who are wealthy and also they are graduated. That means which combination I need to make here? Wealthy and yes. So I'll use my first filter. I'll click on this drop down. You can see there are three categories listed. I will select all. I'll click on this. All are deselected. I'll select here the first one, which is wealthy. I'll click on OK. Similarly, I'll click on the second drop down. I will deselect all. I'll select only the yes and click on OK. So now you can see how many of the people are wealthy and they are graduated as well. So I can select my column and I can see count is coming. You can see I'm rotating my mouse at the bottom. It is showing me count is 6. So wealthy and yes, wealthy and yes is coming. I don't know what is that. Okay. Wealthy and yes is coming as 6. Is it clear what I did?
Ma'am, can you please repeat those steps from home page? Sort and filter.
You can have clicked on the drop down. You need to select the filter here.
Okay, ma'am. Filter.
Filter is applicable. Drop down will be available. You can click on the drop down and one by one you can make all the combinations. Wealthy, yes, wealthy, no. Middle, yes, middle, no. Poor, yes, and poor, no. So I am expecting you, if you are performed one, you please wait. Do not do that. I am calculating everything and I'm writing, and same you can copy. If once you are understanding what I need to do, right? Now I'm selecting wealthy, and with wealthy I'm selecting no here. So count is coming as 5. So wealthy and no count is 5. So I will write here wealthy and no is 5. Similarly, here I'll select now middle. For middle, I'll select firstly, suppose yes, middle and yes. It is coming as 9. Middle and No is coming 7. So it is 9 and 7. So I can write here 9 and 7. Similarly, I'll click on the drop down. Now I'll select the last category, which is poor. I click on OK. I click on the drop down. I'll select yes. I click on OK. So poor and yes is 5. Poor and no is 6. So it is 5 and 6. So this way we calculated this. You can put here it is 5 and it is 6. Done. So you can now write down what I have written here. It is 6, 5, 9, 7 and 5, 6. Done.
Yes.
Now you can see it's 6, 5. You need to take a total. It is very simple total. Up to you. If you wish to sum, you want to use some function that you can use, or directly also you can type it. Because the sum is very small, it is easily you can calculate that. Fine. Up to you whether you want to use this function or not, or you want to rightly calculate it. Up to you. Done, everyone?
Yes.
Not tough, I think.
Madam, I am able to get till selecting the filter, but the number how you just
Ma'am, I have
gave by
selected. Ma'am, I selected this, and it is showing me at the bottom count. So from there, I have taken the count.
oh. Okay, ma'am.
Yeah. Fine. Everyone, it is fine. The contingency table for the object frequency is ready now.
Yes, ma'am.
Now the important task is coming. You need to now see very attentively what I am doing now, right? So I am expecting you. Please wait. Do not perform. Firstly, understand the concept, right? And now, how many object frequencies I am having? Anyone?
1, 2, 3, 4, 5, 6.
6. Very good. I
Hundred.
am having 6 object frequencies. So how many expected frequencies I need to calculate? It is 6. Whatever number of object frequencies I am having, same number of expected frequencies I need to calculate. It is okay? Fine?
Yes, ma'am.
Fine.
Yes, ma'am.
Now, that means if I talk about, I don't know how many of you are belonging to the mathematics, but maybe if I talk about till 10th, I think matrix we have studied, right? So you know this thing, the position of the element in the matrix, how we are reading it according to its row and column reference. So if I talk about this 6 is belonging to this Valdian, yes? Yes or no?
Yes, ma'am.
So when I say this 6, I can say this is first row and first column element, right? So I have written here E11. When I talk about this 5, this is first row and second column element. So I have written here E12, right? Similarly, 9, second row, first column, it is E21. Then 7 is second row and second column, it is E22. Poor 5, this is third row, first column, E31. And this 6, third row, second column, it is E32. Okay. Fine, everyone?
Yes, ma'am.
Fine. So this concept now we are using to fill this expected frequency table. So now this formula I have already told you, it is row total into column total divided by grand total. So one of you were asking me, ma'am, you have written only RTCT. So according to the E11, E12, you will decide which row total and which column total you will select. If I talk about E11, I will select row total 1, row total, column total 1. If I talk about E12, I will take row total 1 and column total 2. Is it clear? Is it clear? Or
Yes.
if not, you
Yes,
can
ma'am.
here, yeah, you can see I have put here a equal sign in my expected frequency table in context to the first combination wealthy and yes, I have kept here equal, right? Now I am selecting this yes and wealthy. This is first row, right? So I'll select this row total multiplied by, I'll select this column total divided by grand total. Is it fine? Wealthy is first row. Yes is first column. Done?
No, wait.
Okay. Row reference means my table is situated from E to H. So you need to see your range of table. I'm not knowing.
Ma'am, can you please repeat again?
Okay, I have kept equal. First row, that is wealthy, no? I selected this row total multiplied by, yes is in the first column, I selected first column total divided by grand total. Done?
Yes, ma'am.
May I enter this?
Yes, ma'am.
Okay, so have you checked? We are getting this value.
Yes, ma'am.
Yes,
Coming
ma'am.
to the next, putting equal here. Now, wealthy and no. So, wealthy is first row. I selected first row total multiplied by no is in the second row or second column. I selected the second column total divided by grand total. Done? Done?
It's
Yes,
5.21.
Sorry, I'm not getting. Is it fine?
Yes, ma'am.
Fine.
Answer is 5.21.
Fine. Now coming to the next, that is middle. Middle is in the second row. I'll select second row total multiplied by middle and yes. Yes is in the first column. I selected 20 divided by grand total. Done?
Yes.
So next is middle and no. So middle is second row. I selected second row total multiplied by no is the second column. I selected the second column total divided by grand total. Done? Done?
Yes.
Now poor and yes category. How many persons of poor and they are saying yes for their graduation level? So poor is in the third row. So I'll select the third row total multiplied by yes first column total divided by grand total. Done?
Okay.
And
Yes,
then
ma'am.
poor and no. Poor is again third row total multiplied by no is second column total divided by grand total. Done?
Yes.
Yes, madam.
Okay. So I think we are ready with our expected frequency contingency table also. Now I'll go for calculating, sorry, the p value. So put equal, type the function CHISQ dot test, right? Select the observed frequency count. So you can see I have only selected the yellow highlighted range, right? Comma, expected frequency count. So total you do not need to select here. This is you need to be little cautious.
P-value
Done?
is equal to
State frequency and observed frequency. This is observed frequency which you have counted. This is expected frequency which you have calculated. Done? Shall I press enter? Yeah. Are you getting this figure?
Yes, ma'am.
Fine. So I can compare this my
Ma'am, can you just repeat which columns need to be selected?
ma'am, only count you need to select. I selected only the counts.
Okay,
Total you do not need to include.
okay.
Done?
Yes.
Yes, ma'am.
Now I can compare this with my level of significance, which is 0.05. I can say it is greater than 0.05. That means I need to accept the null hypothesis. Yes. So what will be? So what will it be? The
null
hypothesis
hypothesis is valid.
validity as a status is independent of graduation label, or you can say there is no association between wealth status and graduation status. Means graduation status is not playing any role in deciding your wealth status. This is the meaning of this particular data. Is it okay?
Yes, ma'am.
Okay. So I hope it is clear. No doubt in this.
No, ma'am.
Right. Second sheet is practice sheet of independence of attributes. Means this is the practice sheet I provided you to perform chi-square test at your own end. Second kind of chi-square test, right? I hope it is okay, friends.
Ma'am, we are
Yes.
accepting null hypothesis. This is not that there is an association between
Yes, ma'am.
wealthiness and graduate.
We are concluding there is no association.
Ma'am, can you show me the hypothesis? Ma'am, both the hypothesis.
Both are null.
Both the hypothesis.
There are two ways of formulating the hypothesis. Both are null. Up to you which way you want to write your hypothesis. Alternative will be there is an association. Right?
Okay, ma'am.
Fine.
Yes.
Fine. So we are concluding here that there is no association between wealth status and graduation status. This is what is the conclusion we are drawing from this. Everyone, it is fine?
Yes, ma'am.
Fine. So I'm now going for conclusion of the session. And after that, if you're having any queries, I'll take your queries, right? So friends, today, although I started little late, I was there in a meeting. So I have started little late. So extremely sorry for that. Today we have talked about a non-parametric test concept. I started with inferential statistics. I talked about parameter and statistic. Two terms I have explained you. And that way I tried to explain you the concept of inferential statistics. Then we started with the non-parametric test concept. And then I jumped on the chi-square test. I tried to explain you what is chi-square test. Usually it is a non-parametric test and based on the categorical data, right? So we are dealing with the count of the data. In that case, we are going for the chi-square test. And especially when we want to see whether there is uniformity in the frequencies or not, in that case, we are talking about the chi-square test, right? There are two varieties in the chi-square test. First one is the goodness of fit. In that case, we will be having the single categorical variable. And in this categorical variable, there is a possibility there can be multiple categories of that variable. So frequencies will be available with you for all the categories. And you want to see whether the frequency is uniformly distributed throughout all the categories or not, right? Hypothesis formulation, I have already told you, we will generally make a hypothesis like there is no difference in the observed and expected frequencies of whatever variable you are taking. Then I talked about the second kind of chi-square test, and I talked about the test of association or independence of attributes. So generally, two categorical variables are nothing but these are known as the attributes, right? So we want to see whether the two attributes are independent of each other or whether they are having any association, right? So we can say we will be having the data available with us. We can prepare a contingency table because we are talking about the Excel. Usually in the other software, we do not need to do this exercise. But in Excel, you need to prepare the contingency tables for expected and observed frequencies both. Firstly, you will prepare for the observed frequency, and using that table, you will calculate your expected frequencies. So formula which you are using to calculate expected frequency is nothing but it is a row total multiplied by column total divided by grand total, right? So simple formula you will use here to calculate the expected frequencies. Once you are having both the tables available with you, you will use chi-square dot test function, and then you can provide the ranges of both the frequencies there, and that way you can get the p-value, right? So this way, this is the whole concept of chi-square test. I have told you we are always testing the null hypothesis, and on the basis of two approaches, that is p-value and the critical value approach, whatever is more suitable to you or you are more comfortable with, that you can use to accept or reject the null hypothesis, right? So I think this was the whole crux or gist of the session. Now over to you people. If you are having any queries, you can ask.
So
Ma'am,
in my version of
yesterday,
Excel, when I'm typing chi-square, there are giving three different options. Chi-square dot inv, chi-square dot inv dot rt, chi-square dot distribution dist dot rt. What are those? And do I have to work on that? Or
I think voice is very slow, ma'am. I cannot hear you properly.
okay, I'll just type
Ma'am,
this
she is
line.
asking when we type chi-square manually, then
Hmm.
many options are there, 4 to 5 options, chi-square dot test, chi-square dot inv, just like written here.
I think you can see I have provided you the three functions chi-square, chi-square dot test, inv are already given to you. You can see here to get the critical value you are using this inverse functions. So this is used for those things. I have already mentioned in your sheet. You can see these are used for these things, but I think as I told you, if you are not comfortable with the comparison of critical value, calculated value, you can only use the first function. But if you wish, I've already given you two functions and what parameters you need to pass inside that. Using that, you can calculate critical value and calculated value, and that way you can compare that. Is it okay? What I said?
Actually, we do not want to use distribution here. Actually, one option chi dot dist is also there in the
We
options
do
for
not need to
chi-square.
use that, ma'am. It is not useful for us presently. So why we will go for the distribution? We will not go for. But the functions which can help you to calculate the chi-square test are chi-square dot test, chi-square dot inv, chi-square dot inv dot rt. That is right-tailed test. RT means right-tailed. So if you are using these functions, in that case, means if you are using the critical value approach, in that case, you need to use these three functions. Or else only one simple function is enough here, that is chi-square dot test function to give you the p-value. Is it okay?
Okay, ma'am. Ma'am, I want to ask one more question. What is degree of freedom? Actually,
Degrees
what
of
is the
freedom.
meaning of degree of freedom?
Degrees of freedom is how many degrees or how many categories are free to take any value. In my case, if you can see, there are 5 categories, right? So out of 5 categories, function formulas is n minus 1. That means 4 categories are free to take any value. Say, for example, if I'm saying the sum of 5 categories is 100, right? So any of first 4 category take any number, but 5th category will always be depending upon the remaining 4. Whatever is the sum of 4 categories is coming, that you can adjust with your total 100, and that way that category will take only that thing. So how many of the degrees are to take any may freely can accept any value? That is the meaning of degrees of freedom.
We can change the value of variables, keeping one fixed.
Obviously, that is the meaning. Yeah, because these things are not fixed, no.
Okay, ma'am.
Thank you so
Ma'am, I
much.
have a question. Ma'am, can you show us how to make a histogram based on mean and difference of mean frequencies? Like yesterday, we discussed mean and difference from the mean deviation. Mean and deviation, no?
Why are you talking about histogram in that case? I'm not getting it, that, ma'am. Histogram is a little different concept. Why you're talking from the mean? Means I'm not getting. Yesterday we were
No,
talking
ma'am.
about standard deviation. That was not
Yes,
histogram.
ma'am. No, ma'am. No, ma'am. Yesterday we talked about standard deviation. In standard deviation, from the given value, we have calculated mean, and from that given value minus mean has become standard deviation. हाँ, मेरा question ये है कि can you, if you know, like, if you know how to do a histogram on Excel, maybe you can show me. Otherwise, if you think it is out of syllabus, okay, no problem.
No, miss. Standard deviation and histograms are not related. I am not understanding. You are want to see how to make histogram, or if you want
Yeah.
to, okay.
I
So
tried, madam, but
in the
it is
data
saying
analysis
something.
toolpack, you can find histogram is given there, ma'am. Give me a second. I'm sharing my complete screen, so that I
I
can.
have
show you.
tried on data analysis toolpack, ma'am. But how to select those values? It is saying I'll
You need
select
to
the
have
entire
bins.
row.
You need to
Select the
have
entire. Yes, ma'am.
You need to have bins for that. Just a minute. Wait a minute.
I did not get you. Till that point I came, ma'am. Till that point I have selected.
So please wait. What I'm saying,
Yes.
I'm saying you. It is asking about the bins. You need to have the range of bins.
Yeah.
Also with you. So bins you need to have, only then we can prepare the data. Just a minute. Just a minute. I need to take a series of data. Yesterday, I think we have used the Excel. Yeah. You can see, right?
Yes, ma'am.
Suppose this is the data available with me, right? But I think this data is not proper. I need to take a proper data with me. Suppose this is the data I'm taking. Give me a second. This is the height data available with me, right? Now you can see what I'm doing.
Insert.
Right? I need to prepare the bins, right? So for preparing the bin, you need to understand what is the minimum and the maximum value of your data. So you can calculate the minimum value. I think I already told you how to get it.
Yes, ma'am.
Right? And similarly, you can use the system. And you can use the max function here. This is the maximum value, right?
Yes, ma'am.
Now you're having minimum and maximum value. Using this, you can prepare the range of your data. Suppose it is 130, 140, 150, 160, and 170. These are the bins I have prepared, right? 160 I missed, just a minute. Now you can go to the analysis toolpack. You can use this histogram. You can give the range of your data. Right? You can give the range of your bins. This is your histogram.
Okay, ma'am. Thank you.
There are some editings you can do that. That way you can remove the, what I can say, the spaces. So I think I'm not going in that, but possibility you can make everything here, right?
Okay. Okay, ma'am.
Ma'am, please you repeat. Can you please repeat the process?
I think I said minimum and maximum value you need to calculate.
After this.
Nothing. You need to go to the data analysis tool pack. You can go to the histogram. In the histogram, you need to provide the data range, bin ranges. In both the cases, I selected the labels of my columns. So I selected the labels, and output I generated at any blank cell. I can select the output range, and I need to select the chart output, last one. And you can click on OK.
Okay.
Okay. So it is okay.
Yes, ma'am. Thank you.
Okay, ma'am. Thank you so much.
Fine. Anything else?
No, ma'am. So far, so good.
Thank you, ma'am.
I have one doubt.
Yeah.
What is the context in which we will use the critical value? As
Critical
opposed to
value
only
always
the-
can be used, ma'am. Critical value is the standard value, right? So calculated value always is provided by means Excel, especially in case of chi-square test, there is a problem because in the data analysis toolpack there is no availability of the chi-square test performance. So that is why we need to depend on the functions, and that is why we have done so many things there, right? But when you're talking about the other tests, Excel is providing you the critical value there and calculated also. So critical value is the standard value of your test, and from that value you will compare your calculated value to decide upon whether you are accepting or rejecting the null hypothesis, depending upon which approach you are using. If you're not using the critical value approach, you will go for the p-value approach for deciding of acceptance or rejection of the null hypothesis.
So this approach selection would depend on the theory that we are applying.
So both the approaches are landing you on the same results. There is no problem with that.
Okay.
So there is no contradiction in those approaches. Only previously people are doing things manually. So that approach was very famous previously, but nowadays when we are using software, so p-value approach is more in fashion.
Okay. Thank you.
Okay. Yeah, fine.
Yes, ma'am. Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you for your patience again.
Thank you so much, ma'am. Thank you.
Thank you so much, ma'am.
Yeah, thank you, everyone. So friends, we are meeting. Yeah, thank you, ma'am. So we are meeting tomorrow, and we will talk about the t-test and all the varieties of the t-test, right? Is it okay?
Yes, ma'am.
Yes. Okay, so thank you, everyone. Meeting tomorrow.
Thank you, ma'am.
Thank you. So over to you, Yogra sir. We are done for the day. Thank you.